Did you, baby?
349,000. You all see it. Rule everything. Ranch, rule everything.
Where is it?
Giles.
The name of the road is Giles?
Giles Road.
Hello?
Hey!
Okay, so I figured out what the problem was, and it was completely my fault.
Oh, bless your heart.
Yeah, my headphones had no microphone in them, so...
Ah, well, that would prohibit one from hearing you.
Yeah, it probably would. So sorry to bother you on your day off.
Oh, no problem. No problem. I'm trying to share the screen with you now, so, you know, the struggle's real for a minute.
Okay.
I don't know why I seem to be able to do this fine on Tuesdays and Thursdays, but apparently have an inability to do it on the weekend. How scary is that?
It's actually probably not that bad of a thing unless help is needed. So, but it's okay. You can take your time. Oh, I see it.
Yes, but you're seeing Algebra 1 right now currently because that was the last thing I used.
I was gonna say I must be really lost if this is what we're learning.
No, that's not what you're learning. So where do you want to start?
To be honest, I haven't done any of the part 2. So if we could start at number 29 and like maybe do one from each section or every other section, that would be awesome.
Okay. Let's see what we can get through. Okay. Hopefully it's taking a century to get this erased. Okay, and just to confirm while I'm doing that, number 29, to make sure I have the right worksheet, is f of a equals negative 3a squared plus 8a plus 5?
Yes.
Okay, I just wanted to make sure I thought I pulled the right one, but I wanted to make sure.
Okay.
Okay, so the instructions say evaluate each function at the given value and then determine if the given value is a 0 of the function. That's the instructions. So simply all you do is plug in that 3 into the equation. So it would be 3 squared here plus 8 times 3 plus 5. So you've got negative 3 times 9 plus 24 plus 5. So that's negative 27 plus 24 plus 5. That's going to be negative 3 plus 5. So that's a 2. Is that the right answer?
Yes, I got that far. This entire 0 thing, I just am really struggling with.
Okay, there's all kinds of different ways to get the zeros. Okay. But obviously the zeros of any function are where they cross the x-axis. In this particular one, when you're given this is kind of known as the remainder theorem. And so if you plug in a value into the original equation and you come up with a value other than 0, it's not a 0. If the answer to the equation is 0, then that was in fact a 0.
Okay, that makes sense.
Okay.
Okay.
All right. So, and so on that one, since you have the answer sheet technically in front of you, if we were just going to kind of review that whole section to make sure you understood it, because I feel certain that you can plug in these values and get an answer. I feel pretty good about you being able to do that.
Okay.
But if you look at the answers for number 29, for number 30, 31, and 32, there's only one that has the answer 0, which is 30.
32.
So that means that 2 would in fact be a 0 of that function.
Okay.
Does that make sense?
Wait. Hold on. Are you saying that 2 is a 0 of the function for number 29?
No, ma'am. Oh. Number 30. What I was saying, if you go to your answer sheet and look at the answers for 29, 30, 31, and 32, only one of them has the answer 0.
Okay, and that's 30. Okay, I got
That's
that.
30, which would then, if you go back and look at number 30 on the review sheet, it's m squared minus 4 at m equals 2. So that tells you m equals 2 is one of the zeros for that function.
Okay, yes.
Okay.
Now I understand.
Okay. Is that, I was just trying to make you understand the whole concept since we're only doing one from each section.
Yeah. Okay, I understand that.
Okay. So you feel pretty good about that one?
Yes, I do. I was just confused on the last part of the instructions, but I understand now. So.
Okay, great.
Okay, and then I haven't done division in, it feels like forever, so
Okay.
33.
Okay. Now, if I'm remembering correctly, you liked long division better than synthetic.
Yes.
However, on every single one of these problems, synthetic division is possible. Which one do you want to do right now?
If we could do, I think long, but you know what? Let's just do synthetic division. It'll be faster.
Yes, synthetic is faster, but if you understand long, I don't mind doing that.
I understand both of them. I'm just trying to see which one would be best for me to grasp right now in time for the test. So,
I would definitely say synthetic. I can't remember this portion of the test because it's at school. So I don't know if the only time you can use synthetic division is when it's a monomial, like the n plus 10 or x plus 5. If it's a trinomial or a binomial, you know, like a quadratic, if you will. If it's quadratic or higher in degree, you can't use synthetic division. You can only use it. So I don't know if that makes sense to you, but if you see that all the divisors are 9, like n plus 10 and x plus 5, you know, they're little simple factors. That's the only time you can use synthetic.
okay, that makes sense.
So on all of these, you can use synthetic division. So you take the opposite of your divisor. So that would be negative 10. Do you see where I get that? Okay. And then you do this crazy little thing. And you write your 5. And I always try to take a look at first to see if I need to have any fillers. But I don't because it goes 3, 2, 1, 0. So I'm fine. I don't need any fillers.
Okay.
Placeholders, fillers, whatever you want to call them. 75 and a negative 43. So you see where I get all of those? I'm just writing in my coefficients.
Okay, I'm working it out on a piece of paper with you, so.
Okay.
You know.
Are you good?
Yes, ma'am.
Okay, so I bring my 5 down. Let's bring it down, and then 5 times negative 10 is negative 50. And technically, we're adding over here. But obviously, in this case, when you add a negative to a positive, you're really subtracting. But
yes.
So that's 8. And then 8 times negative 10 is negative 80. So that gives us a negative 5. And a negative 5 times a negative 10 is a positive 50. So that's going to give me a positive 7. So my answer should be, you take your first and you take your this is your coefficient, and then this began as an n cubed, so this will be squared plus 8n minus 5 plus 7 over x plus 10, because this part's your remainder.
Okay. Okay.
How do you feel about that?
I feel better about it.
Okay. Do you want to do one more?
I think that would be good.
Okay. Do one more?
Yes, that'd be great. Thank you.
Okay. Oops. Wrong button. All right. We'll just do the next one. How about on this one, I'm going to write stuff down and you tell me what to do next.
Okay, that sounds good.
That way you'll feel a little more confident about what you're doing.
Okay.
Just takes me a lot longer to erase. Technology, it's a blessing and a curse. Okay, so what is my divisor going to be?
7.
Good job. All right, now what am I going to write through here?
5, negative 45, 63, and 59.
Good job. No placeholders needed?
No.
Okay. Okay, now what do I do?
You bring down the 5.
Good job.
You multiply it by 7, which gets you to 35. So you add that, which brings you to a negative 10.
Good job.
Multiply that by 7, which brings you to a negative 70. And the answer to that is negative 7, right?
Yes, ma'am.
Okay. Multiply that by 7, it's negative 49, which brings you to a positive 10.
Yes, ma'am. Now
So
what?
the answer is 5p squared minus 10p minus 7 plus 10 over p minus 7.
Good job.
Okay.
You did it.
That's good.
You did it. All right, so we can move to the next section. How do you feel about factoring?
1 second.
I think tomorrow's factoring is factor by grouping.
Okay, I'm a little better at that. So
I think the factor by groupings are toward the bottom, like 45, 46, 47, and 48. I cannot remember if there's other factors in there. You know, like where the coefficient for the letter A is not 1. I can't remember if there's those on there or not. How do you deal with those? You do okay?
I think so. I honestly can't remember.
Okay. Do you want to do 41 just to try it?
Yes, that would be awesome. Because I usually blank on the test when it comes to those.
Okay.
Mrs. Park, this is Patricia.
Yes, ma'am.
I just want to thank you so much for your grace and for doing this on a Sunday night. You're very gracious. I appreciate you.
Oh, no problem. Glad to help. Glad to help.
God bless you. Thank you.
God bless you. Uh-huh. Okay, so this part right here, I always draw these little lines, and then I'm hoping that that will kind of trigger something for you guys to remember it. That you're going to multiply these coefficients. So if I multiply 4 and negative 30 together, I get a negative 120. So what I'm looking for now at this point is I'm looking for two factors when combined together, multiply to be 120, when added, give me a negative 19. So I know that one of them is going to be negative and one is going to be positive because that's the only way I can get a negative number multiplied. And then I know the larger of the two is going to be the negative one because my result here is negative.
Okay.
All right. So I'm just going to start factoring because I really don't know what the answers are. So that's kind of what you have to do.
Okay.
And so then I start kind of playing with the numbers. I got 12 and 10, which that doesn't do much for me. I've got 20 and 6. I don't think that really does anything either, does it?
I don't think so. Let me see.
3 and 2. So that's factored all the way. So 15 and 8 don't do anything.
Are you working it out on the screen?
Yes. Can you not see it?
No, I can't. It froze on 10 and 12.
Oh, it did?
Yeah.
Uh-oh. All right, let me see. Did that do anything?
You just scrolled down a little bit.
Yeah, did it show up some other numbers? Because I wrote some things below 10 and 12.
Yeah, it did. Okay.
Oh, okay. All right. So I'm just trying, at this point, I'm just trying to factor and come up with factors that combine to give me a negative 19.
Okay.
And okay, so now I'm just taking a look at some of these things. Because you have to take all these factors and then combine them in different ways to get that negative 19.
Okay.
Okay?
Uh-huh.
2 times 2, that'd be 8.
Yeah, did you write the number 8 on the screen?
No, this is a 3.
That makes sense. Sorry, I'm just not the best with technology.
That's a 3.
Okay.
So I'm just now what I'm doing is combining, making different combinations to see what I can get that gives me a negative 19.
Okay.
Okay. So I've got this would be 4. And then that'd be 15 times 2 is 30. That's not going to do it either. So, 6 and then 20, 12. This is 40. Six.
One second.
Negative.
Sorry.
6.
Ben has yawned 4 times since I laid down, but I was picturing doing this like an hour ago when we were working. I said I'm gonna do that one of them, and he's yawned 4 times.
I got it. I was like, it's taking me forever. It's 24 and 5.
Okay.
Okay. Does that make sense? It's 6.
Somewhat.
This part right here. 6, 24. Those are your two factors. 24, a negative 24, and a positive 5.
Mm-hmm.
Okay. Those combine to give you a negative 19. And
Right.
when you multiply them, give you 120.
Okay.
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 It took me a while. Sometimes it does, probably late at night. But okay, now here's the key. When you plug it back in, so you can't stop there though. You have to divide this by the leading coefficient. Okay. This actually comes out even. So that's going to be A minus 6. This doesn't. So you bring the denominator over here to make that 4A plus 5. And now it's factored.
Okay.
Did you like the Xbox diamond method better?
To be honest, I don't really like either of them. I just didn't really do well with either of them, so.
Well, it's totally in the whole next chapter too, and pretty much for the rest of Algebra 2. And it's in pre-calc too. So that's the ugly news of it. So it's one of those things like we're just going to keep having these because it just needs to be something that you get for the rest of the because when you get to rational expressions, you can't really solve some of the things that you need to solve without factoring.
Okay.
I will say this, though. Not very many of them have leading coefficients that aren't 1. This doesn't happen that often until calculus.
Okay.
That's kind of the good news about that.
Nice.
Yes.
I just am so bad at math that I always blank. Like when it comes to tests or quizzes, on the spot, I always blank because I don't know why I can't memorize things. So let's just hope that doesn't happen.
Well, this really is, this isn't the only part that you really need to quote unquote memorize is that you have to multiply your A and your C coefficients. Other than that, it's a little bit of trial and error with your factoring. And then once you get those two factors, getting it to this point and moving it to here. But all of that is just calculation. But there is a little bit of manipulating numbers when it comes to this part.
Okay.
And that's just everyone. I mean, I do this obviously a lot, and every now and then I get one that's a lot of times like the ones that don't have a leading coefficient. I see those almost instantly because I've been doing it for so long. But some of these I have to really think about and manipulate the factors a little bit more to get where we need to be. Does that make sense?
Yes, ma'am.
It's just practice. But you feel better about the factors by grouping?
Yes, for sure.
Okay. All right.
Okay. That's good.
Okay.
Do you still have time? Because if not, it's totally fine.
Yeah, I can do a few more. Let's hit 49. Or do you want to do some more? Do you want to try one of the grouping ones before we move to a different section?
That would be great because I'm still kind of lost.
Okay, on the grouping?
Yes.
Or do you want to do another with a leading coefficient other than 1?
Are there going to be a lot of those on the test? I don't know if you could tell me that. But
like I say, I don't remember what she had on part B because Miss Stone is the one that made the test, not me.
Okay.
But I do know there's grouping. That part I do remember. So
okay.
Let me just move to that.
Okay.
All right. So I'm going to do the first grouping one, which is number 45. 15x cubed minus 21x squared minus 5x plus 7.
Okay. I don't know whether or not you're casting the screen, but I can't see it. So.
Oh, you can't? Hold on. I am casting it. So.
Okay. It disappeared a few minutes ago, but I didn't know why. So.
Oh, and it just told me that you left the call.
Oh, okay. Well.
I wonder if you need to hang up and come back in.
Okay, we can do that.
All right, I'll just wait here.
That's fine.
Oh, that's weird.
Maybe around 11. 6. And a quarter of 6.
Okay, I'm back.
And can you see the screen?
Nope, I just see your profile picture.
Ugh.
Goodness gracious, technology is stressful.
It is. It is. Okay, there you are. And
wait a sec, you can see me? Because I turned off my camera because I look disgusting.
No, I cannot see you.
Okay, great.
I can see your little profile thing that lets me know that
Okay.
you're there.
That's good. I was going to say, I don't think anyone wants to see me right now. That would be bad.
I feel exactly the same way because my hair fell in my face and I have a big orange bow in my top of my head.
Oh, that's great.
Yes.
I just look bad. No specific reason.
Okay, let me try. What do you see?
Okay, there we go. It's back.
Yay!
Magic.
Okay. Yes. All right. Now this one is a little more interesting because unlike other, well, no, it'll work. Yeah, it'll work.
Okay. What exactly will work? Just this in general?
Well, there's multiple ways to approach this one. I'm just trying to figure out. A lot of times what I like to do is hopefully it's going to default.
Mm-hmm.
I like to hope that it's going to default to where you can just group them like that automatically. Sometimes you have to move them around, which actually moving them around in this case might have made a little more sense, but we're going to try this.
Okay, sounds good.
Okay, so I group them and we're going to take out a 5 out of this first part, which would leave me 3. Is that what I want to do? No, that would give me 5x. Give me yeah, I don't know if that's what I want to do or not. Yeah. Yeah. Actually, I'm going to manipulate these a little bit.
Okay.
I'm going to move them 5x cubed minus 5x minus 21x squared plus 7. And now I'm going to group them.
Okay, that seems to work better.
Yeah, 5x. Leave me 3x squared minus 1. And then I'll take a...
So it wouldn't be minus 0. You would have to put a 1 there?
Yes, ma'am. Because how many times will 5x go into 5x?
Oh, 1. Okay, that makes sense.
And then I'm going to take a negative 7 out of this, which will give me a 3x squared minus 1. And then I'm going to factor out this and this, which would leave me 5x minus 7, 3x squared minus 1.
I love it when it works like that.
Yes, it's a beautiful thing. So sometimes you have to manipulate your numbers, move them around. Just when you're doing that, make sure that you move your signs when
Okay.
you go.
Okay. That makes sense.
Okay. All right. Now, describe, oh, no, not that. I flipped my paper over. State the possible rational zeros for each function. Number 49 and 50. Basically, that's that P over Q. You remember that?
Very vaguely.
Okay.
I'm sure I have notes on it somewhere.
Okay. Well, P over Q is the constant and the leading coefficient of A.
Mm-hmm.
And those are all your possible zeros.
Oh, I remember that. Yes.
Okay. So if you look at number 49, what are the factors of -5?
Just -5 and +1, right?
Yes, and vice versa.
Vice versa.
So you would that's your P, and then you would put that oh, please no. Put that over your Q, which are the coefficients for A, or for the P, which is technically also A a lot of times, which is 5 in this case.
Okay.
So P over Q. And your P is -5 and 1 and +5 and -1. So then the same really would be, so because you've got -5 and 1 for each of them. So basically you're kind of looking at this, because you have to put that all the way across, and then you would have to actually do the same thing. So basically what you're looking at more is that -5, actually ±5 and ±1/5 and ±1. Does that make sense?
Yes. So for the Q, like no matter what the problem is, are you saying it's going to be the same number?
No.
Like,
I did. No, I wrote that poorly. I'm just going to redo that. The factors for P are negative, ±5 or +/-1. And the factors for Q are +/-5 and +/-1. So you have to put each of those, you have to put 1 over 5, 1 over -5. You have to put each one over each one, and then you just narrow it down.
Okay. That makes sense.
We'll have things that are repeating.
Okay.
So that's why I narrowed it to this.
That makes sense.
So like on number 50, the P and the Q are 1 and 3 and 1. So all of your possibilities are going to be ±1 and ±1/3. Does that make sense?
Yes.
Okay, because the P is the constant at the end of the problem and the Q is the leading coefficient.
Okay.
So you're taking all of the factors for P and all of the factors for Q, and you're making them a ratio.
Okay, that makes sense.
So that's all 49 and 50 are.
Okay.
And then 51, 52, 53, and 54. That's Descartes' rule. Let's see. Possible. Which has to do with sign changes. Do you remember talking about that or seeing that?
Kind of. You're going to have to remind me.
Okay. That was what we did. I think what happened is we did 2.7, and then on actually it might have been 2.6. We did 2.6, and then we kind of circled back and did some stuff on 2.1 for our 2.7, 2.6 on our homework. And so there's a particular page in the book that would be really helpful for that one. And let me pull that up real quick, because I want to make sure that you really study it while you're doing these problems.
Okay, I have my book here, so.
Okay, great. That is going to be, I think it's in 2.6. Now I can't remember the exact page. Oh, of course, my book just logged me out because technology is my friend. So head toward 2.6.
I'm there already.
And do you see? Ooh, too fast.
Because I see the P over Q rational zero theorem.
Okay. And then maybe it's in 2.7. Oh, yeah. Yes, it is in 2.7, and it's on page 140.
Got it.
And it's called the Descartes rule of signs. And so that's the positive real zeros, the negative real zeros, and even the imaginary, but they're only going to ask about positive and negative in this case. So what you're looking at is you're taking the number of sign changes that go throughout the problem. So if you look at number 51, there's only, so one sign change because the front is positive to a negative. That's one sign change. And then the next one is negative to positive. So that's two sign changes. And so if the sign changes twice, it's either 2 or 0 number of positive, because you have to subtract 2 from it. So let me write it up here.
Okay.
27x to the 6th minus 224 x to the 3rd plus 64. Okay, this is there's an understood positive here. Agreed? So there's a sign change here, so that's 1. And then there's a sign change here, so that makes 2 sign changes. So then the next thing you have to do is then so there's 2 or, and then you have to take this and subtract 2 from it, and it's 0. So wherever, like just pretend it turned out to be 3, it'd be 3 or 1. So you have to take whatever it is in reality, like the number of sign changes. So the possibility is there is either going to be 2 or 0 positive zeros for this function. Does that make sense?
I understand the 2 or 0. The 3 or 1 kind of threw me off. Like, okay. Can you explain?
That was just, I was trying to explain that if this had turned out to be a 3, that you have to subtract the 2. That you always subtract 2 from whatever number this is.
Oh, okay. So you don't, okay, that makes sense.
So like if it was 5, you actually have to do 5, 3, or 1. So you have to keep saying subtracting 2.
That makes sense. I thought since the answer to the first one was 2 or 0, I thought that you were just like, if there were 3, it would be 3 or 0. I thought you just subtracted the number that there was. But I understand.
No, that's why I wanted to clarify it, because you're always subtracting 2.
Okay, I understand.
You're going down by increments of 2.
Okay.
All right, so now let's take a look at this, because then it's asking you for the negative. Okay, the positive one is just starting with the problem as is. And then the negative ones are if you actually are changing the coefficient in there. So you're actually making, like if this were 27 times a negative x to the sixth minus 224 with a negative x to the third plus 64. All right, now what would happen if you multiplied a negative x and raised it to a 6? Nothing is going to change on that. It's still going to remain positive, right? Because a negative times a negative times a negative, when it's an even number, it's always positive. So this one's actually going to turn out to be positive. Does that make sense?
Uh-huh.
Okay. So you'd still have that. But in this case, a negative times a negative is a positive, times a negative is a negative. So I'm actually multiplying a negative times a negative. So this is going to turn out to be 224, a positive.
Mm-hmm.
Right?
Right.
Okay. So that, and then that's going to be a plus. So there's actually no sign changes for this one.
Okay.
So the number of negative zeros is 0.
Oh, okay, that makes sense.
Because there's no sign changes.
Okay.
All right, so this is just about sign changes.
Mm-hmm.
And you have to remember that whatever the top number is. So what's interesting about this, just so that you understand the full Descartes rule, remember how there was 2 positive or 2 or 0?
Yes.
Okay. And now there's 0 negatives.
Mm-hmm.
That tells me that, remember, the number of possible zeros is the same as the number of the highest degree.
Yes.
That tells me that then there's a possibility of having 4 imaginary zeros in this particular function, which means basically it's not going to cross the x-axis very often.
Okay.
So that's the whole reason that you're doing this activity.
Okay, that makes sense.
Okay, but that's all 51, 52, and 53, and 54. That's all you're doing there is looking for sign changes.
Okay.
All right?
Yes.
And then the possible rational zeros for each function, then find all the zeros.
Mm-hmm.
State the possible ones. Once again, that's that lovely P over Q thing.
Uh-huh.
Okay. Then from there, you would actually use those possibilities and either factor or use synthetic division or use your calculator to find out where they're crossing the x-axis.
Okay. Oh, I remember how to do that. So.
Okay.
Okay.
So, but you can, what you're going to do is like when you see your calculator, wherever it's crossing the x-axis, if you can see one where it's positively crossing the x-axis at a 2, then you want to divide that out and then get the rest of your zeros. But stating the number of possible zeros for each one, there's a possibility of 3, and on number 55, it's going to be all those, the factors of -1 and 2.
Okay.
Okay, now, do you feel good about that, or do you want me to actually do one?
I'm sure I can figure it out.
Are you sure? I don't mind doing one.
Are you sure? Because I already feel bad enough taking up this much of your time on the weekend.
Let's see.
It's honestly fine.
Well, because I'm going to do one real quick, and then we need to talk about the end behavior. Why don't the end behavior at the bottom, the 59, the 61, 60, and 62, the end behavior.
Mm-hmm.
This is where just kind of, this is where your leading coefficient, if it's negative, that's, you know, it's either going to be a happy face or a sad face.
Yeah.
Kind of thing. And then that the degree is going to be the number of turns. Do you remember that?
Right.
That it's going to have?
Yes.
And the other thing that you can do always is you can obviously graph it and see what it looks like.
Mm-hmm.
But this first one, because it's odd, it's going to emulate kind of a line. Because and it's positive, so that means it's going to be more like a positive slope. So it's going to fall left and rise right. I always like to think of a line as the simplest form of an odd degreed trinomial or polynomial, and a quadratic as the simplest of an even. And I'll show you that. But let's go back to 55. 55. Do you have your graphing calculator in front of you?
Yes, I do.
All right. I'm just going to write this down and put in, okay, P over Q, and then I'm going to have you graph it. But P over Q in this case, all of my factors for -1 are going to be plus and minus 1, and all my factors for 2 are going to be plus and minus 2 and plus and minus 1. So I'm going to have 1 plus or minus 1 plus or minus 1/2. Those are all my possible zeros for number 55.
Okay.
Plus or minus 1 plus or minus 1/2. All right. Can you tell when you graph it where it goes through?
I haven't graphed it yet. 1 second.
Okay.
Let's see. It's fair. On like one of them, it's definite.
Okay. It should look pretty clear on all of them.
Yeah.
Because the answers are -1, -1/2, and 1.
Yes.
So is it
I
kind of
see
going
it.
up and down scriggly?
Uh-huh.
Okay. So the other thing that you could do on that one is actually go to your table if you wanted to and see your zeros. If your table was in increments of halves, you'd be good.
Okay.
But that's how you do those.
That makes sense.
All right. And then go ahead and graph number 59.
Mm-hmm. Okay. 1 sec. I'm so slow with these calculators.
I'm not really speedy with them either. And today I was tutoring Ellie McDowell, and hers, the graph would show up for about a millisecond, and then it would go to syntax error. So I don't know what was wrong with hers.
Ooh. Okay, I graphed it.
Okay, so it should be where you see it falling to the left and rising to the right, does it?
Yes.
So that's all you would write down for something like that.
Oh, okay.
So But let me show you something like x cubed, the one you just did, minus 4x squared plus 7. It's an odd degreed polynomial with a positive leading coefficient. So if you'll think of a line where the slope is positive, you go over 1, up 1, over 1, up 1, like that. So it kind of looks like this. So it's rising to the right and falling to the left.
Oh, I like that.
Okay?
Okay.
So think of it as your parent odd polynomial, because a line has a degree of 1.
Okay.
Okay? Because it's just y equals mx plus b. So it has one little sweet little x.
Okay.
Okay? All right. So if the slope was negative, it would go left and then up 1, right?
Yeah.
And then left and then up 1. So it would go like this. So it would rise to the right and fall to the left.
Okay.
If it had a negative leading coefficient. So your line is your parent odd thought process, okay?
Okay.
And then your beautiful little quadratic that we focused on in chapter 1 is the parent of your evened ones, because our sweet little parabolas were squares. Remember those? So if you think about your parabola, when it had a positive coefficient, so if it was x squared plus x minus 2, then what it was, because the leading coefficient is positive, it was a happy face parabola. Right. So it rises to the left and it rises to the right. So your even ones are like that. If it was if the leading coefficient were negative, it would be a sad faced parabola. So it falls to the left and falls to the right. So the parabola is your parent function for all of your even degreed polynomials.
Okay.
Okay. So that means, let's just say now, if you have x to the 6th, and then you've got all your fancy stuff after that, but it's positive over here, that just means it's even. So the parent is going to be the parabola. So it's going to be rise to the left and rise to the right. But if this happened to be a -2, it would be falls to the left and falls to the right.
Okay.
So your degree will tell you if you're going to focus on the line or focus on the parabola. Does that make sense?
Yes, ma'am.
As your parent. And so and then the leading coefficient tells you whether it's going to be happy or sad.
Okay.
Or what the slant is.
Okay, that makes sense.
Okay. All right.
Thank you so much. Teacher of the Year award. You win.
Oh, whatever. You're so sweet. Thank you for trying so hard. I appreciate it.
And I really appreciate you understanding my situation. And I know that I've told you about how stressful it's been, so I really appreciate this.
Not a problem. I understand.
You sometime this week.
Okay, that's fine. That's fine. I just want you to understand it. That's what's most important to me.
Okay, thank you.
All right, have a blessed evening.
You too, thanks.
Bye-bye.